Hello, welcome to video 18 of the option pricing and option trading strategy series. Today I'd like to talk about a position known as a conversion. Conversion. It's a compound position. It involves two options and stock. Specifically, the position involves plus long 100 shares. It involves one position in a put with an exercise price X and a timed expiration T. And it involves a short position in a call with the same exercise price and same remaining time to expiration. Because these are the same, exercise price and time to expiration, this put-call pair are referred to as twins. Okay? So this position is known as a conversion. This position is, important that you know this, risk-free. Now what's risk-free mean? Risk-free means that you're guaranteed a certain value at some point in the future. So the idea is here, this has a certain value, no matter what, at some point in the future. Let's kind of think through this now. So we want to think through the aspects of both exercise and assignment. Okay? Exercise and assignment. We're going to look at both of these. And for example, this is our position. Long 100 shares, long the put, short the call. It's known as a conversion. And let's think about what happens to this position at option expiration. Let's say at option expiration, let's just say stock price is equal to the strike price. This will be our first circumstance. We'll say, so if the stock price is equal to strike price at option expiration, OE, well then both the call and the put expire worthless. We don't have to buy to close the call. We're not going to sell the put. They're just going to expire worthless. And then we're left with 100 shares. At what price? The stock price, which is equal to the strike price. So at that point in time, we have a value of 100x, okay? And then we have to remember to sell our shares, in the after hours or whatever if we want to leave our equity exposure. Well, the second of the three possibilities is if the stock price is greater than the strike price at option expiration. Well, if that's the case, if stock price exceeds the strike price, the right to sell at X then will be worthless. So the long put will expire worthless. So this expires worthless. This long put expires worthless. But the call that someone owns will be exercised, either exercised by them or auto-exercised. And they're buying the shares at the contractual price X. Because we wrote the call, we had what was a contingent obligation. Since we've been assigned, it's now no longer contingent. It's just an obligation to sell 100 shares. And we have 100 shares to sell because we own them, okay? So we're going to sell those 100 shares. So we'll sell 100 shares per our short call assignment obligation, okay? And when we sell those calls, what's in our account? Well, when we sell those shares, what's in our account? Well, we just sold 100 shares, that's gone. The put expired worthless, and we got a sign on the call, so the call vaporized, so all that's in our account is 100 shares that we sold for X dollars each, or 100X, okay, in cash, okay? And that's all we got, okay? Interesting. That was the same as we had up here. After we sold the shares up here, okay, it was 100x cash is what we had in our account. Third possible situation, if stock price is less than strike price, okay? So this is number 3. If stock price is less than strike price, well, if that's the case, then the call will expire worthless, so we don't have to buy to close. Before OE, and after the moment of expiration, it's too late. We'll have to deal with exercise or assignment, of course. And then, but the put will, that we own will auto-exercise. And what's a put give me the right to do? Sell 100 shares. At what price? The contractual price, X. Okay? So I'm going to sell 100 shares at X. The call expired worthless. The put exercised, auto-exercised, so it vaporizes. And the shares I sell are those 100 shares that I have. If I didn't have those shares, I'd end up with a short position in the stock. And so in that case, what we're left with is 100 shares that we sold for X. So we have 100X cash. Now, what do we just see? That in each of these positions, no matter in each of these circumstances, which describes the universe of possible outcomes of the value of S relative to X, and nothing else could happen. It's either equal to, greater than, or less than X. S is, that is. And so that means that no matter what happens, the value of this position, this conversion at option expiration is 100X. And that's what makes it risk-free. Just like a treasury bill that matures at $1,000 at some point in the future, that's what makes it risk-free. This too is risk-free. Okay? Now, of course, it says nothing about the purchasing power of that 100X, but that's a separate story. It's still risk-free. And so there we go. What I've proven to you here now using the exercise and assignment scenario is that a conversion is a risk-free compound position. Okay? It's a risk-free compound position. Risk-free. All right. Very interesting. So now we're going to make use of this observation, a very, very important observation, to make some simple observations. So at option expiration, okay, when the markets are in equilibrium, so at OE, when markets are in equilibrium, the following is true. S plus P minus C equals X. Now, what this is this is the per share equivalent version of what we saw up here with this position right here. Okay, the conversion. Down here we have the per share equivalent of that. Okay, this is the per share equivalent of that. S is 1 share of stock. P is effectively 1/100th of a put. C is effectively 1/100th of a call. And X is also a per share value. Obviously, just as stock price is obviously a per share value. I mean, I don't even know if that's worth mentioning, but it's true, okay? So at option expiration in equilibrium, this is true. Well, just like a treasury bill is worth $1,000 in the future, and because of that, you know its value prior to its maturity date, as long as you can observe risk-free interest rates in the market to discount its value back. Just like that, the same is true with this. So at all times, I'll keep it in red, at all times in equilibrium, at all times in equilibrium, that means not just at OE, but all times, S plus P minus C will equal the present value of the strike price. And this is also written as X times e to the minus RT. Okay, continuous discounting. E to the minus RT is a continuous discount factor. Okay, it's a present value interest factor with continuous discounting. Okay, kind of like what we've seen before, 1/1 plus R to the N. Here you discounted a periodic opportunity rate of return R once per period for each of N periods, but here it's continuous compounding. And x times that present value interest factor is the present value of x. So I'll change back to my favorite color, blue, and I'll write it again. At all times in equilibrium, we don't always have equilibrium, but what I'm talking about here is an equilibrium relationship. So at all times in equilibrium, S plus P minus C equals the present value of the strike price. This is very important. This has a name. This is known as put-call parity. Put-call parity. S plus P minus C equals the present value of strike price. Put-call parity. Interesting. And what we're going to see now is that, the existence of this put-call parity is going to lead us to the ability to create synthetic securities. Kind of a big deal. Well, I can write a sloppy note-like thing that says this: S plus P minus C equals 0 risk. Okay, that's true. I mean, it's not math. It's just kind of notational, right? Notational, right? It's not really a lie, but it's not math. Like this is a mathematically. This is a mathematical formula describing an equilibrium financial relationship. And now I'm just making a sort of notational S plus P minus C equals 0 risk. Okay, that's true. And now here comes a lie. I'll call it a trick. It's going to help us. I'm now going to write S plus P minus C equals 0. Now this is not true. Okay? It's not true because S plus P minus C equals that. Present value strike price right there. But this is just helpful. So it's a helpful lie. Okay? But it's more of a trick than a lie. I'm just accentuating. Now, let's pretend that that's true. Let's pretend that S plus P minus C does equal 0. Pretend S plus P minus C does indeed equal 0. Well, this implies a bunch of stuff. This implies that S plus P equals C. Yeah. Now, what's that mean? Well, here, very important. What this means is the following. S is certainly a real share of stock. P is certainly a real 1/100th of a put, theoretically. And it says that that is equal to C. Now, what's that tell us? That tells us that I can create a synthetic call option, specifically a synthetic long call, by buying stock and buying a put, where the put and the call are twins. Very interesting. And there's a lot we can do with this. We'll learn about it in other videos. Right now, we just want to learn about creating synthetics, creating synthetic securities. And for example, this is a synthetic long call. Well, what would a synthetic short call be? Well, I just leave the minus C here and take the S and P over to the other side. So minus C equals minus S minus P. Well, that's going to be a synthetic short call. Why? Well, minus C is a real short call, and it's equal to this. And therefore, we will see that they are the same thing. Other things are implied. I'll change the color just to keep it interesting. Okay. This also implies, look, S minus C equals minus P. Well, this is a real short put. This must be a synthetic short put. Right? So the synthetic short put is this. Up here, the synthetic short call is this. Up here, the synthetic long call is, again, that. Okay? Well, I could just, I could keep the P where it is and move the S and the C to the other side up in this equation here. And this is a real put. This then must be a synthetic long put. Synthetic long put. And then, well, goodness gracious, we can even create synthetic stock. I'll just leave the S there and move the P and the C to the other side. This is real long stock. This must be synthetic long stock. And the last one would be to take the S to the other side, and that would make, when I move it over, it makes it a minus S, negative S, and P minus C. Well, this is real short stock, and that's equal to this, long put, short call. And so this must be synthetic short stock. There's synthetic short stock. A long put and short call or synthetic short stock. And that's all I have to say in this video, where I'm explaining the nature of the theory that lies behind put call parity. Thanks for watching.